Fine. Go get engineering. Let me explain wind load pressure variation for walls in line with your question. So your question is if you would have to calculate one wind pressure and apply it throughout the entire height of the structure. Now, the response to that question is going to be based on the code requirement. So you need to look at me. You need to listen very carefully and understand the requirements. Now, when you're calculating the dynamic wind pressure, you typically would have to calculate the dynamic wind pressure in orthogonal directions for doubly symmetrical building structures on plan, as the code requires. Okay, so it specifies 45-degree directions, okay, plus or minus 45-degree directional range, with critical wind attack directions in orthogonal directions being more onerous. So the 90-degree interval, which is 0, 90, 180, 270 degrees, are the critical directions in which you would have to evaluate your wind pressures. Now, these wind pressures are a function of the external and internal pressure coefficients for walls, okay, and for roofs. But your question now relates to the reinforced concrete structure. Your question is, are you going to calculate in the determination of the wind pressure in this direction? For this is 0-degree direction. Okay, are you going to evaluate a single dynamic wind pressure and apply it throughout the entire height? The answer is no or yes, subject to the code requirements. And so I'm going to take you through what the code specifies for walls. Now, the code specifies that to determine the number of levels in which you are going to calculate the wind pressure variation. Remember, the wind pressure varies with height. Okay, so the higher the building is, the lesser the drag against the wind pressure, and then you have higher wind velocity profile, and then you have automatically higher wind pressures. The pressure is directly proportional to the square of the wind velocity. In compliance with the expression, have rho v square. Now, what the code specify is that, now before I take you to this section, we need to look at figure 7.5. Now, you will apply or calculate the wind loads in orthogonal and non-orthogonal directions, but you can reduce the critical directions in which you will evaluate the wind loads in the orthogonal directions. Okay? Now, in the x direction, so you calculate the wind load in 0 degrees, 90, 180, and then 270. So depending on the software you use, if this normal to the longitudinal direction of the building is your 0 degrees, then this automatically becomes your x-axis, depending on the software. So this is your x, and that's your y, and z is upwards, that's perpendicular to this plane. Then you will have to apply the wind loads in those orthogonal universal coordinate system directions. But let's remain on the concern, which is the height that you need to consider in determining your wind pressure. Now, the code specifies that if you apply your wind pressure or your wind load in the 0 degree direction, 0 degrees is the direction that is perpendicular to the longitudinal span of your building. Now, what you have to look at, there are three conditions that will determine the pressure variation or the number of magnitude of pressure variation that you take into consideration. Number one, if the height of your building is less than b, then you consider only one height at which you would determine your wind pressure. So in this case, let's look at the structure that is being designed. Now, for this structure, in this direction, the overall length of the building is 27.58, and then the height of the building is 20.7. So wind in the 0 direction, this is the crosswind breadth. Okay, this is your B. This is the crosswind dimension. Now, so if you go back to the code, it says if the height is less than B. So in this case, the height of the building is less than the crosswind direction. The implication in this instance is that you're going to calculate a single wind velocity pressure. So in the derivation of your wind load, okay, so in the derivation of your wind load, your velocity profile, okay, your velocity profile is going to be evaluated at one elevation. So that velocity profile and your turbulence intensity is going to be calculated. So you look at turbulence intensity, function of length Z over Z0. So Z is that height, and then your Z0 is your roughness length, subject to the category in which your building is situated. Okay, so in this instance, this is the case that applies to the number of wind pressure variation. Okay, the number of heights in which the wind pressure is going to be evaluated. Now, so it also specifies that a height that is greater than the width but is less than 2b, you will have to evaluate your wind pressures in two heights. Okay, so the height, or at two elevations, you have to calculate your wind pressures at two elevations. So if the height again is greater than the crosswind direction, okay, but the height is actually less than 2 times the crosswind direction, the first elevation you will have to consider is the crosswind direction, okay, and then the second elevation is the height minus the crosswind direction. And so you're going to use those two elevations. You see, first elevation is ZE, second elevation is H. Now, this applies to wind in this direction. Okay, so 90-degree wind applicable to this building in this direction. Let's see how that impacts. So if you're applying the wind load in this direction, so we look at the building dimension in that direction, the crosswind dimension. So if I look at from here to there, let's check. Again, I said you have to look at the crosswind dimension. So if I look at, we would have to look at from here okay, so I missed out the correct dimension. So you look at okay, so you look at from there to there, right? So you look at from there to there. Let me take out this dimension. Right. So if you look at the crosswind dimension from there to there, you're having 16.87. So 16.87. So I'm to apply the wind load in that direction. If I'm to apply the wind load in this direction, so this is 16.87, and then the building height is what? Is 20.7. So the building height is greater than the crosswind dimension, but the building height is less than twice the crosswind dimension. So the cross dimension is 16.87 times 2, which is 33.74. Therefore, you're going to calculate wind pressures in two heights, okay, at two governing elevation. The first elevation is at elevation 16.87, and the second elevation is at elevation 20.7 minus 16.87. So you're going to calculate the wind dynamic pressures at these two elevations in this direction. It's those two elevations that you're going to consider in the analysis of this structure. Thank you.